Imagine finding a doorway cut into a mountain, only to discover that no one knows where it was meant to lead. Picture standing beneath a stone weighing hundreds of tons and realizing that its builders left no record explaining how they moved it. Then imagine uncovering strange symbols, sealed chambers, unfinished monuments, and structures whose original purpose disappeared with the people who created them. These are not legends invented centuries later. They are physical places that can still be measured, excavated, and examined today. Yet the deeper archaeologists investigate them, the more unanswered questions seem to remain. Today, we enter the ancient world through the mysteries it never explained. Yangshan Quarry contains the remains of a monument so oversized that its 3 stone sections would have weighed more than 31,000 tons and risen nearly 80 meters if they had ever been assembled. Yet none of them made it out of the quarry. They remain cut into the limestone hillside outside Nanjing, China, where work stopped more than 6 centuries ago. The project began in 1405 under the Yongle Emperor of the Ming dynasty, who ordered an enormous commemorative stele for the Ming Shaoling Mausoleum of his father, Zhu Yuanzhang, the Hongwu Emperor and founder of the dynasty. This was not an abandoned monument, whose builders or purpose have been forgotten. Its historical setting is unusually clear. What is much harder to explain is why an imperial administration capable of organizing some of the largest construction projects of its age allowed workers to proceed so far with stones whose movement would present an almost unimaginable logistical problem. The plan followed the basic form of a monumental Chinese stele, but enlarged to an extraordinary scale. Instead of carving one monolith, workers prepared 3 enormous limestone components: a base, the main tablet body, and a crowning head. Measurements vary slightly between modern descriptions because the unfinished stones remain integrated with parts of the quarry, but commonly cited figures give the base as roughly 17 meters high, 29.5 meters wide, and 12 meters thick, with an estimated weight of 16,250 tons. The main body was planned at approximately 51 meters in length, 14.2 meters across and 4.5 meters thick, weighing about 8,799 tons. The crown measured around 10 meters by 22 meters by 10.3 meters and weighed another 6,118 tons. Together, the 3 components amount to approximately 31,167 tons. Had they been finished and stacked according to the intended configuration, official Nanjing descriptions place the monument's total height at about 78 meters, comparable to a modern building of more than 20 stories. The surviving quarry makes clear that this was more than an ambitious proposal that never progressed beyond planning. Workers physically attacked the mountain on a monumental scale. Yangshan provided massive beds of limestone, and instead of extracting manageable blocks and assembling the monument from smaller pieces, quarrymen outlined huge sections directly within the living rock. Deep channels were opened beside the intended stones, gradually separating their vertical faces from the surrounding hillside. The unfinished body still lies horizontally against the mountain, with a narrow channel dividing it from the unfinished head, while other cuts expose the enormous volume that workers intended to isolate. The surfaces retain the physical geometry of the quarrying operation: trenches, rough-cut faces, and areas where stone was deliberately left connected to the bedrock. These traces are important because they show exactly how far the project advanced. The enormous forms visible today are not natural formations interpreted later as monuments. They are unmistakably the products of an organized extraction operation. That surviving evidence makes the 16,250-ton base the most difficult part of the project to understand. Cutting around such a mass was already a huge undertaking, but complete separation would have transformed a stationary section of mountain into an object that somehow had to be controlled. Until the final rock connections were removed, the mountain itself supported the stone. Once detached, its entire mass would have needed to be transferred onto some combination of prepared ground, timber structures, sledges, rollers, or another transport system capable of surviving loads far beyond those involved in ordinary building work. Even distributing 16,250 tons across hundreds of contact points would have produced enormous pressures. A small failure beneath one side could tilt the block, crush supporting material, or make further movement impossible. The problem was therefore not simply generating enough pulling force, it was keeping an object weighing thousands of tons stable while forcing it to move in a controlled direction. And leaving Yangshan would only have begun the challenge. The intended destination was Ming Xiaoling, near Nanjing, meaning that these stones were supposed to travel many kilometers from the quarry to the mausoleum. Moving monumental stone was certainly not beyond Ming engineering. Chinese builders possessed sophisticated knowledge of roads, sledges, hauling systems, and coordinated labor, and the Ming state demonstrated an exceptional capacity to mobilize workers and resources. But Yangshan represents a completely different order of mass. The smallest of the three pieces was still estimated at more than 6,000 tons. The largest exceeded 16,000. No surviving transport installation at the quarry demonstrates how loads of that magnitude were supposed to begin their journey, and no detailed Ming transport plan explaining the intended operation has survived. This absence does not mean that mysterious machinery once existed. It means that the precise logistical solution imagined by the project's planners remains uncertain. What survives is the stone itself, frozen at the point before that solution had to be proved in practice. Transport was not even the final problem. At Mingxiaoling, the pieces would have needed to become a vertical monument. The approximately 8,799-ton tablet body had to be raised into position above the enormous base, followed by a crown weighing more than 6,000 tons. A structure approaching 78 meters in height would also have required carefully prepared foundations and extraordinary control during erection. Raising a tall monolith is fundamentally different from dragging one horizontally. As the center of mass rises, small errors become increasingly dangerous, while ropes, timber frameworks, earthen ramps or lifting systems must resist immense forces. Even if the stones somehow reached the mausoleum intact, the problem of stacking them into a stable 31,000-ton stele would have remained. The unfinished quarry therefore preserves only the first stage of a sequence in which every subsequent stage became more difficult. This is what makes Yangshan so unusual. The Yongle government was not inexperienced with large projects. His reign became associated with enormous state undertakings, including the development of the new imperial capital at Beijing, construction of the palace complex later known as the Forbidden City, and the maritime expeditions commanded by Zheng He. The state could mobilize vast numbers of workers, specialists, materials and supplies over long distances. Yangshan was therefore not the fantasy of an isolated community attempting engineering it had never encountered. It emerged from one of the most powerful administrative systems of its time. That makes the scale of the miscalculation, or ambition, more striking. The weight of the limestone did not suddenly increase once quarrying began. The dimensions could be measured, and the approximate volume was visible from the start. Yet huge amounts of stone were removed before the project stopped. The enduring question is not whether Ming quarrymen understood how to cut limestone. The quarry demonstrates that they did. It is why the imperial project was allowed to reach this stage before the consequences of its scale ended it. Karahunj, also known as Zorats Kara, is one of Armenia's most puzzling prehistoric monuments, because dozens of its massive standing stones were deliberately pierced with circular holes whose original purpose is still unknown. The site lies on a high plateau near Sisian in southern Armenia, about 1,770 meters above sea level, and contains roughly 223 recorded megaliths. Some rise nearly 3 meters above the ground and may weigh several tons, with the largest estimates approaching 10 tons. They are not arranged as one simple stone circle. Instead, Zorats Kara includes a central enclosure, long northern and southern arms, a northeast alley, additional stone alignments, isolated monoliths, and numerous burial structures spread across several hectares. Archaeological surveys therefore suggest that what survives today was probably not created in a single construction phase, but developed and changed over many centuries. The most unusual feature is concentrated in approximately 84 stones that contain carefully formed holes, usually positioned near their upper sections. Most openings are only several centimeters wide, yet they pass directly through dense volcanic rock, often basalt or andesite, and point in different directions. Some are nearly horizontal, while others angle upward toward the sky or toward specific sections of the horizon. Creating these openings was not a trivial task. Basalt is extremely hard, so producing a narrow perforation without splitting the block would have required controlled drilling, pecking, abrasion, or repeated grinding. More important is the repetition. A single hole could have served an ordinary practical purpose, but dozens of similarly placed openings across an entire megalithic complex suggest a deliberate system. No surviving wooden fitting, rope arrangement, metal component, or other object has been found that clearly explains what that system was. This is why Zorats Kara became closely associated with archaeoastronomy. Armenian researchers, including archaeologist Onik Khnkikyan, astrophysicist Elmer Parsamian, and later radiophysicist Paris Herouni, examined whether some of the pierced stones could have functioned as fixed sighting devices. The principle is simple. An observer positioned behind one hole would see only a narrow portion of the horizon or sky, allowing repeated observation of the same direction. Herouni and other supporters of the observatory interpretation proposed that certain stones corresponded with positions of the sun, moon, or bright stars, including possible alignments connected with solstices and equinoxes. If those orientations were intentional, the stones would have worked like extremely simple stone instruments, using no moving parts but preserving fixed lines of sight for celestial observation. The astronomical interpretation remains controversial because orientation alone cannot prove intention. With more than 200 stones and dozens of openings pointing in different directions, some apparent matches with celestial positions can occur by chance. Archaeoastronomers have therefore warned against using proposed star alignments to assign extremely ancient dates to the monument without supporting archaeological evidence. This is one of the central problems at Karahunj. A hole may point toward where a particular star rose thousands of years ago, but that does not establish that the builders created it for that star. To demonstrate an observatory convincingly, researchers would need the orientation, construction sequence, archaeological context, and dating evidence to support the same conclusion. At Zorats Kara, those pieces do not yet fit together securely enough for a consensus. Excavation has instead produced strong evidence that burial was one of the site's major functions. Numerous stone-built graves and cists have been discovered among and beneath the megaliths. During investigations in the 1980s, Khnkikyan excavated more than a dozen tombs containing artifacts mainly associated with the Bronze and Iron Ages. Some burials have been assigned approximately to the 10th through 8th centuries BC, while material from other areas is substantially older. A grave exposed beneath a large upright stone in 1931 contains contained objects attributed to the Middle Bronze Age, and pottery associated with central funerary structures has been placed around the 15th and 14th centuries BC. Later excavations identified pottery and burial material from additional phases, including finds dating approximately to the early 2nd millennium BC. These discoveries show that Zorats Kera was reused repeatedly. Excavations conducted during the 2010s revealed tombs containing material from several periods, indicating that the same funerary spaces could be reopened generations later. Some burial complexes included pottery associated with the 18th and 17th centuries BC, together with later Bronze and Iron Age remains. This creates an important dating problem. Archaeologists can date pottery, charcoal, bone, or other material recovered from sealed contexts, but the stone itself cannot be directly radiocarbon dated. Even if a grave beside a monolith dates to a particular century, that does not automatically prove when the stone was erected, and it certainly does not prove when its hole was cut. The standing stones, burials, and perforations may therefore belong to different stages of the site's history. There is another complication. Archaeological surveys have suggested that some upright stones may have been reused as elements of later walls or defensive structures. Research involving German and Armenian specialists around the beginning of the 21st century interpreted much of the site primarily as a prehistoric necropolis and proposed that certain alignments were incorporated into later construction. If pierced stones were moved from their original positions, even a genuine astronomical alignment visible today might no longer represent its first orientation. This possibility weakens attempts to treat the entire surviving complex as one precisely planned ancient observatory, but it does not explain why the holes were created in the first place. Takht-i-Bahi contains one of the strangest architectural arrangements found in the Buddhist ruins of ancient Gandhara, a group of stone chambers built at such a low level that the floor of the courtyard above is effectively level with their roof. From the upper complex, covered stairways descend toward these rooms, while vaulted passages continue through the structure and toward the valley below. Early archaeologists even described them as subterranean vaults. Excavation later showed that they were not literally underground chambers cut beneath an existing building, but deliberately constructed low-level rooms incorporated into a monastery that expanded across a steep hillside over centuries. That distinction makes the site more interesting, not less. Takht-i-Bahi was not designed as one simple monastery on a flat platform. Its builders created a dense vertical complex of courts, stupas, cells, retaining walls, covered stairways and vaulted passages, occupying different elevations of the same mountain. The ruins stand in present-day Khyber Pakhtunkhwa, Pakistan, within the ancient cultural region of Gandhara. UNESCO places the foundation of the monastery in the early 1st century AD, although archaeological chronologies proposed for parts of the complex extend back into the 1st century BC. The religious settlement remained active for centuries, with major additions continuing into the 6th and 7th centuries AD. Instead of replacing older architecture, successive builders frequently expanded around it. The result is a complex in which structures belonging to different periods physically intersect. The court of many stupas, monastery, kitchen and refectory have been assigned to an early phase extending roughly from the 1st century BC through the 2nd century AD. The main stupa court and assembly structures are generally placed later, around the 3rd and 4th centuries. The court of 3 stupas belongs to another stage, and the low-level chambers are usually associated with the final centuries of occupation. These dates, however, are not equally secure. Scholars studying Takht-i-Bahi have repeatedly warned that several architectural phases remain hypothetical because the early excavators did not leave enough stratigraphic evidence to date every building precisely. The low-level complex demonstrates just how unusual this development became. Archaeological descriptions record 10 rooms arranged in 2 rows on opposite sides of a narrow vaulted passage. Their ceilings were constructed using corbelling, with successive courses of masonry projecting inward until the space could be closed above. Their flat upper surface reached approximately the same elevation as the floor of the neighbouring lower court, effectively allowing one architectural level to rise directly over another. H. Hargreaves's excavation in 1910 to 1911 clarified that these rooms were later additions and were not bonded into the retaining wall beside them. Access was possible through doorways from a courtyard to the west, and from stairs entering the central passage from the south. The rooms have commonly been interpreted as meditation cells, but their exact use cannot be reconstructed with certainty. What survives is the engineering arrangement itself, a deliberately compressed series of stone spaces inserted beneath the working level of an already complicated religious complex. Immediately beside them is an even less easily explained structure. Archaeological descriptions record an enclosure approximately 50 feet square, or about 15 meters on each side, surrounded by walls reaching roughly 30 feet or 9 meters high. It possessed only a single entrance. No convincing physical evidence survives inside to reveal exactly what activity required such a tall, enclosed quadrangle. Alexander Cunningham, who examined Takht-i-Bahi in the 19th century, interpreted it as a general meeting place for the Buddhist fraternity, partly because of its form and small holes in the walls that he associated with oil lamps. Later descriptions have continued to discuss it as an assembly or conference space, yet archaeological surveys also acknowledge that its original purpose is uncertain. Beside a monastery filled with recognizable cells, stupas and devotional architecture, a 15-meter wide enclosure with towering blank walls and only one controlled entrance remains an unusually ambiguous component. The surrounding architecture makes the problem harder to isolate. Takht-i-Bahi spreads across hilltops rising between roughly 37 and 152 meters above the surrounding terrain, and the Buddhist complex itself covers tens of hectares. Builders worked with local dressed and semi-dressed stone, arranging it in the characteristic Gandharan diaper masonry pattern and binding the construction with lime and mud mortar. Instead of leveling the entire mountain, they adapted buildings to the rock and changing elevation. Retaining walls created platforms, narrow stairways connected courts at different heights, vaulted corridors passed beneath or beside buildings, and some structures rose in more than one story. South of the low-level chambers, a long passage descended toward the valley. Above part of this route stood small stupas decorated with stucco. Religious monuments, circulation routes, and structural engineering were therefore layered into the same limited terrain. At the heart of the site, the density increases again. The Court of Many Stupas occupies a lower area between the monastery and the elevated main stupa court. Historical surveys describe dozens of votive stupas and surrounding chapels concentrated within this relatively confined space. The monastic quadrangle contained cells around a central courtyard and a water reservoir, while kitchens, refectory spaces and other rooms made the institution capable of supporting a permanent community. This was not simply a shrine visited occasionally by pilgrims. It functioned as a large religious establishment whose builders repeatedly had to solve the problem of fitting sacred, residential and communal architecture onto a steep and irregular ridge. Archaeology has gradually exposed how complicated that history was. Takht-i-Bahi was reported by European observers during the 19th century and examined by Alexander Cunningham in the 1870s. More systematic work followed under the Archaeological Survey of India, D.B. Spooner conducted major excavations beginning in 1907, and Hargreaves worked there in 1910 to 1911, including investigation of the low-level chambers. Further large-scale archaeological work was carried out by Pakistan's Department of Archaeology and Museums between 2002 and 2005. Yet the early clearing of the ruins created a lasting chronological problem. Architecture was exposed long before modern excavation methods could document every soil layer, construction interface, and associated deposit. Researchers can compare walls, masonry techniques, and the ways structures join or fail to join one another. But some phases cannot be assigned an absolute date simply from architecture. Ocriculum preserves one of the strangest pieces of Roman urban engineering in central Italy. An enormous supporting structure, about 80 meters long, divided into 12 vaulted spaces arranged on 2 levels, built to carry a monumental terrace whose main building has almost completely disappeared. The ruins stand near modern Ocriculum in Umbria, beside the Tiber and the ancient Via Flaminia. Archaeologists usually call this structure the Great Substructures, but these vaults were never meant to be the monument itself. They were a hidden structural system designed to hold back the slope, create an artificial platform, and support something important above it. The problem is that the superstructure is largely gone, leaving the foundations far clearer than the building they once served. Suggestions have included a sanctuary, a capitolium, a political religious complex, or spaces connected with storage, but no interpretation has been proved beyond doubt. The mystery becomes more interesting when the great substructures are viewed as part of a much larger engineered landscape. Ocriculum covered roughly 36 hectares and developed across sloping ground, descending toward the Tiber. Roman builders did not simply place streets and monuments wherever the terrain allowed. They reshaped the terrain itself, retaining walls, filled terraces, vaulted chambers, and artificial platforms were constructed at different levels to create stable surfaces for public buildings. In several areas, ordinary-looking ground was actually supported by masonry below, leaving visible monuments above and concealed engineering beneath. The surviving remains show that Roman construction here involved not just architecture, but large-scale manipulation of an entire hillside. One of the clearest examples is the area around the theatre and baths, where the builders had to deal with running water. The San Vittore stream crossed the slope chosen for monumental construction. Instead of avoiding it, Roman engineers redirected the water through a subterranean channel and created an artificial terrace above. The stream continued beneath the newly shaped urban surface, while buildings occupied the ground overhead. Archaeological reconstruction indicates that this hydraulic intervention belonged to an early phase of development in the area, meaning later monuments were built on top of a landscape that had already been altered. This is one of the most striking details at Ocriculum. The engineers were not simply leveling a courtyard or supporting a wall. They were changing the relationship between water, soil, and architecture in order to make the site usable. The theatre makes this hidden system easier to understand. Built around the transition from the 1st century BC to the 1st century AD, its cavea measured about 79 meters across, and its orchestra roughly 15 meters in diameter. Part of the seating used the natural slope, but other sections required structural support and artificial leveling. Rooms and vaulted spaces helped carry parts of the cavea, while the area in front depended on modified ground. The visible monument therefore rested partly on the natural hill and partly on constructed terrain. Much of the stage architecture has disappeared, yet the surviving structural elements show how carefully the theatre was fitted into a slope that had already been engineered. The bath complex adds another layer. Large baths were built on the artificial terrace above the diverted watercourse, and surviving rooms show that the architecture was technically ambitious. One circular room is about 9 meters in diameter, while an octagonal hall once belonged to a richly decorated complex that included a large polychrome mosaic. The baths were not placed on untouched soil. They occupied ground created through retaining, filling and drainage work. Water ran beneath a man-made terrace, while monumental rooms stood above it. This vertical arrangement is one reason Ocriculum is more unusual than a normal ruined Roman town. Its most remarkable feature is not a single hidden chamber, but the way several engineering systems were stacked together. The great substructures remain the most difficult feature to explain because the monument above them cannot be reconstructed securely. Their construction is generally placed around the late Republican to early Imperial period, approximately the late 1st century BC to the early 1st century AD. Their elevated position and monumental size have encouraged comparisons with sanctuary terraces elsewhere in Roman Italy. A sacred precinct has been proposed, and a Capitolium has also been suggested. The colossal head known as the Jupiter of Otricoli, discovered during 18th century excavations, has sometimes strengthened the idea that an important temple once stood nearby, but the connection is not certain. The sculpture and the terrace may belong to the same religious landscape, yet there is not enough surviving architectural evidence to prove that the great substructures specifically carried a temple of Jupiter. Construction details show that this was never a minor retaining wall. The surviving complex extends for around 80 meters and is formed by 12 large spaces on 2 levels, with masonry that includes Roman concrete and opus reticulatum. Some upper rooms preserve traces of wall treatment, while the lower sections reveal the amount of material required simply to stabilize and reshape the slope. The builders had to manage earth pressure, heavy loads, drainage, and the surrounding topography at the same time. None of this requires unknown technology, but the scale remains remarkable. Roman engineers were effectively creating a new piece of land large enough to carry monumental architecture where the natural hillside did not provide one. The wider site reinforces that interpretation. Ocriculum possessed a theatre, amphitheatre, baths, nymphaeum and forum area. The amphitheatre had an arena approximately 67 by 45 meters, while the monumental nymphaeum extended for about 50 meters. The artificial terraces were therefore part of a wider urban strategy for building monumental spaces on difficult ground. That imbalance is what makes Ocriculum such a strong ancient mystery. The hidden systems survived better than the monuments they were built to support. The vaults still reveal how the hillside was stabilized. The underground channel still shows how water was controlled. Artificial terraces preserve the shape of ground that did not originally exist. Yet the major structure above the 80-meter substructure remains uncertain. Ocriculum does not need claims of impossible technology to be mysterious. Roman engineers transformed a natural slope into a layered urban platform, using vaults, retaining structures, drainage and redirected water. But one of the most important buildings in that system disappeared so completely that modern archaeology can describe the support beneath it more confidently than the monument itself. Sudama cave is cut directly into the granite of Barabar hill in Bihar, India, and its most striking feature is not simply its age but the condition of the stone inside. Created in the 3rd century BC during the Mauryan period, the cave contains 2 carefully shaped chambers whose walls and ceilings were worked to an exceptionally smooth, reflective finish. The outer chamber measures about 9.98 by 5.94 meters, while the inner room is nearly circular, roughly 5.8 meters in diameter, and covered by a hemispherical vault. A long vaulted hall leads through a narrower opening into the rounded chamber beyond. More than 2,200 years ago, craftsmen had to remove a large volume of hard granite, control the geometry of these spaces, and then continue refining the stone long after the rooms themselves had already been hollowed out. The date is unusually secure because an inscription at the entrance records that King Piyadasi, the name used by Emperor Ashoka in his edicts, dedicated the cave to the Archaeologists. Written in Prakrit using Ashokan Brahmi, the inscription belongs to Ashoka's 12th regnal year and places Sudama firmly in the 3rd century BC. This gives the site something many ancient rock-cut monuments lack: direct evidence linking it to a specific ruler and religious community. The Archaeologists were an ascetic movement that existed alongside early Buddhism and Jainism, yet their own textual tradition later disappeared almost completely. The cave therefore tells us clearly who received it, while leaving far less evidence about what they actually did inside. The engineering problem begins with the granite. Barabar Hill is formed from extremely hard stone, much less forgiving than sandstone or limestone. Excavating a cavity nearly 10 meters long would already have required enormous effort, but Sudama goes far beyond simple excavation. Its walls, curved roof, and inner dome-like chamber were brought to the highly smooth finish, commonly called Mauryan polish. Large areas are reflective enough for light to move across them, and the finish extends over curved surfaces as well as flatter walls. No surviving Mauryan manual explains the exact sequence of tools, abrasives, or polishing compounds used. What remains is the finished result: granite that had to be roughly cut, leveled, progressively refined, and then polished until broad areas lost almost all obvious tool marks. Nearby Lomas Rishi Cave helps reveal the process, because parts of its interior remain unfinished. Its rougher zones show that the polished appearance was not a natural quality exposed simply by cutting into the hill, but the result of an additional finishing stage. The mystery is therefore not whether Mauryan craftsmen could polish granite. They clearly could. But how they organized the tools, abrasives, and labor needed to achieve such a consistent finish over rooms of this size. The geometry adds another difficulty. Sudama was not carved as one crude rectangular shelter. The outer hall has a barrel-vaulted roof, while the second chamber changes into a nearly circular space beneath a hemispherical ceiling. Every adjustment had to be made inside a single mass of stone. If too much granite was removed from one section, it could not be replaced. The builders therefore had to control depth, curvature, and alignment as excavation progressed. The rounded inner room is particularly important because irregularities would have become more obvious once the surface was polished. Its shape strongly suggests that the craftsmen were working toward a planned geometry rather than simply following natural fractures. The polished granite also creates one of Sudama's most unusual effects: powerful reverberation. Hard, smooth stone reflects sound efficiently, and the curved interior causes voices and sharp noises to linger and return through the chamber. A pronounced echo can be heard, especially in the rounded room. This has encouraged suggestions that acoustics may have mattered in the cave's original use, perhaps during chanting, meditation, or communal ascetic practice. No surviving inscription, however, states that Sudama was intentionally designed as an acoustic chamber. The effect is real, but whether it was planned or was simply a consequence of polished granite and curved geometry remains unresolved. The layout makes that uncertainty more interesting. A visitor first enters the long outer hall, then passes through a narrower opening into a smaller circular chamber where both the visual and acoustic environment changes. Unlike many later Indian rock-cut monuments, Sudama is largely undecorated. Its impact comes from proportion, darkness, curvature, polished stone and sound, raising a basic question: why invest so much labor in finishing bare granite surfaces to this degree if the cave was only practical shelter? Sudama was not an isolated experiment. Other caves at Barabar and nearby Nagarjuna preserve the same Mauryan tradition of highly polished interiors. Ashoka dedicated caves at Barabar to the Archaeologists, while Nagarjuna caves were later associated with his successor, Dasaratha, showing that this technique could be repeated under royal patronage. Yet the mirror-like treatment did not become the standard finish of later Indian cave architecture, making Barabar a distinctive early technological phase. The Ajivika connection deepens the historical mystery. Ashoka is most famous for his association with Buddhism, yet the Barabar inscriptions document royal patronage given to another ascetic movement. The effort required to carve and polish these caves suggests that the Ajivikas held real importance during the Mauryan period. Even so, they later disappeared as an independent tradition, and much of what is known about them comes from inscriptions or texts written by rival communities. Their connection to Sudama is therefore clear in stone, but poorly explained in surviving literature. We know they received the cave, but the exact rituals, daily practices, and symbolic meaning attached to its unusual two-room design remain uncertain. Later damage to some Barabar inscriptions adds another layer. References to the Ajivikas were deliberately chiseled in several cases, although enough of the original writing remained for scholars to reconstruct the wording. Who did this and why remain unknown, but the damage shows that the religious identity of the caves was contested after the Mauryan period. Sudama Cave remains compelling because its mystery is built into measurable features rather than legend. Its date is anchored by an Ashokan inscription. Its dimensions can be recorded, its granite surfaces can still be examined, and its acoustic behavior can still be experienced. What is missing is the technical and ritual explanation behind those facts. The builders removed a substantial volume of hard granite, shaped two different geometries inside one hill, polished broad surfaces to a reflective finish, and created a chamber where sound behaves in an unusually dramatic way. More than 2,200 years later, the physical result survives with remarkable clarity, while the exact methods, labor sequence, and intended experience behind it remain only partially understood. Fugoppe Cave, near the coast of Yoichi in western Hokkaido, Japan, preserves one of the most unusual collections of ancient rock carvings in the country. Inside a chamber, only about 5 meters deep, 4 meters wide, and 5 meters high, archaeologists identified hundreds of engravings showing human figures, animals, boats, geometric marks, and, most famously, strange human-like forms with projections resembling horns or wings. Beneath its small interior is an archaeological deposit around 7 meters thick, containing pottery, stone tools, shells, and objects made from bone and antler. The carvings were discovered in 1950 and investigated soon afterward, but more than 7 decades later, their makers, exact age, and meaning remain uncertain. What makes Fugoppe especially mysterious is that this type of petroglyph is extremely rare in Japan. Similar engravings exist at nearby Temiya Cave, but there is no broad Japanese tradition that clearly explains why these figures appeared here in northern Hokkaido. The most striking images are the anthropomorphic figures. Some appear to have horn-like projections rising from the head, while others show extensions from the shoulders or sides of the body that have often been described as wings. Archaeologists do not interpret them literally as winged creatures. More cautious explanations suggest shamans, ritual costumes, ceremonial masks, or symbolic beings connected with beliefs that have not survived in written form. Traces of red ochre suggest that some figures may originally have been colored. The artists did not simply scratch soft stone. Fugoppe is formed from hard volcanic rock, and the engravings were produced through a combination of pecking, cutting, and abrasion. Researcher Masaru Ogawa noted that this technical mixture is unusual and proposed that the artists may have adapted familiar rock art methods to the difficult local stone. Pecked imagery has parallels elsewhere in Northeast Asia, which has led to the possibility that Fugoppe was connected with cultural traditions extending north towards Sakhalin, the Amur region, and the Eurasian continent. This remains a hypothesis, but it raises the possibility of influence from farther north. Dating the carvings is equally difficult because the figures were cut directly into rock and cannot be radiocarbon dated in the same way as charcoal, bone, or wood. Archaeologists have therefore relied on stratigraphy, pottery, shells, geological evidence, and decorated fragments that fell from the cave walls. Accelerator mass spectrometry, dating of shell samples and studies of the cave's formation suggest that major human use began around 2,000 years ago. Much of the archaeological material belongs to the post-Jomon period, with the strongest occupation generally placed around 1700 to 1500 years ago. On that basis, the engravings were long associated with the people who occupied Fugoppe during this period. But the discovery of fallen carved stones complicated the chronology. Excavators recovered roughly 60 fragments bearing petroglyphs from different depths within the cave deposits, including one found near a massive fallen block that geological interpretation linked to an earthquake roughly 1900 years ago. If that decorated fragment fell during the same seismic event, at least some of the carvings must already have existed before the cave's main occupation reached its peak. Ogawa therefore argued that part of the rock art may be approximately 1900 years old, potentially older than much of the pottery and other material found inside. This leaves open one of Fugoppe's most intriguing possibilities. The people who later occupied the cave may not have been the people who created its images. Fallen engraved fragments do not appear to have received special ritual treatment, and some stone inside the cave was reused for practical purposes. If the later occupants considered the carvings sacred or fully understood their meaning, archaeologists might expect clearer evidence that decorated pieces were treated differently. Instead, they seem to have become part of ordinary occupation debris. That pattern may indicate that the symbolic system behind the petroglyphs had already weakened or disappeared by the time another community used the cave intensively. The number and arrangement of the images also suggest that Fugoppe was not decorated casually. More than 800 engraved figures and marks have been reported, concentrated across a surprisingly small interior. Ogawa observed enough stylistic similarity among many carvings to suggest that they may have been produced during a relatively limited period rather than accumulating randomly over many centuries. If so, Fugoppe could record a short-lived ritual or artistic tradition that appeared in northern Japan and then vanished almost completely. The nearby Temia cave proves that Fugoppe was not entirely isolated, yet the scarcity of comparable sites makes it difficult to reconstruct the wider culture behind them. No inscription identifies the figures, no surviving tradition explains the horned or wing-like forms, and no direct dating method has fixed the moment they were carved. That combination is what makes Fugoppe Cave so valuable as an ancient mystery. Archaeology can reconstruct the sequence of occupation, identify the materials left behind, measure the deposits, and use shell dating and geological events to narrow the chronology. But the central questions remain open. The carvings may represent ritual specialists, supernatural beings, ceremonial costumes, or symbols introduced through contact with Northern Asian cultures. The earthquake evidence may even indicate that some of them belonged to an earlier population whose beliefs were already fading when later people occupied the cave. In a chamber only a few meters across, Fugoppe preserves hundreds of images from a tradition that left almost no explanation behind. The figures are still there, but the language of symbols that once made them meaningful has disappeared. Pedra Formosa is one of the most unusual surviving monuments of Iron Age Portugal. A huge decorated granite slab, almost 3 meters wide, more than 2 meters high, and about 24 centimeters thick, yet pierced near the bottom by an opening so small that anyone entering the chamber behind it had to crouch deeply or crawl. The best-known example comes from Sitania de Briteiros, a major fortified settlement of the Castro culture near Guimarães in northern Portugal. The slab measures about 2.90 meters across and 2.28 meters high, and its position inside a bath structure has made it one of the clearest examples of a strange architectural tradition found in northwestern Iberia. They stood between rooms in compact stone bathhouses where heat, water, and restricted movement were deliberately combined. Archaeological evidence shows that the building associated with Pedra Formosa functioned as a steam bath or sauna rather than an ordinary washing room. Comparable Castro period bathhouses contain a sequence of spaces leading toward a heated chamber, with furnaces or combustion areas used to heat stones. Water could then be poured over the hot stones to produce steam. The narrow opening in the Pedra Formosa makes practical sense because a small doorway reduces heat loss from the inner chamber. Yet this only explains part of the design. If retaining heat had been the only goal, the builders could have used a plain partition. Instead, they shaped enormous granite slabs and sometimes covered them with complex geometric decoration. At Briteros, repeated curving and linear motifs associated with Iron Age art turn a functional doorway into the visual center of the structure. The opening itself changes how the building must have been experienced. A person approaching the heated chamber could not remain upright. The architecture forced the body downward before entry, creating a sharp transition from a cooler outer space into a confined room filled with heat and steam. That physical action has led archaeologists to ask whether these bathhouses had meanings beyond hygiene. Steam bathing is strongly supported by heating installations, water management, and room layout, but their social role is much harder to reconstruct. Some researchers have suggested purification, communal ceremonies, or rites of passage. No inscription explains what happened inside, so these interpretations remain hypotheses. What is clear is that the builders invested far more effort in the threshold than simple temperature control seems to require. Pedra Formosa was also not an isolated invention. Similar sauna buildings are known from several Iron Age sites in northwestern Iberia, particularly northern Portugal and Galicia, although not every bathhouse used the same monumental decorated slab. The recurring combination of heated chamber, narrow passage, outer room, and combustion area shows that the basic technology was repeated, but variations in decoration imply that individual communities treated these places differently. Briteros stands out because of both the size of its stone and the richness of its carving, making it difficult to regard it as nothing more than an oversized heat barrier. Citania de Briteros itself adds important archaeological context. The hilltop settlement contained stone houses, streets, defensive walls, water channels, and public buildings. 2 bath structures have been identified there. The East Bathhouse was first recognized in 1932, recorded again in 2006, and excavated in campaigns during 2016 and 2018. Archaeologists documented surviving architecture and stratigraphy connected with its construction, abandonment, and destruction. They identified damage from stone robbing in the modern period and additional destruction caused by the construction of National Road 309 in the 1930s. This disturbed history matters because the famous Pedra Formosa had already been removed from its original setting centuries before archaeologists could study it properly. Historical records state that the slab was moved to the churchyard of Santo Esteban de Briteros in March 1718. Francisco Martín Sarmiento had it returned to the Citania in 1876, and it later entered the museum in Guimarães in 1897. By then, crucial archaeological context had been lost. Early researchers proposed funerary or sacrificial functions because they were studying an enormous carved monolith without the complete building that once surrounded it. The discovery of comparable bath structures gradually changed that interpretation. Modern excavations support the steam bath explanation, but the original relationship between the famous detached stone and the surviving bath remains harder to reconstruct because of centuries of removal, reuse, and destruction. Other sites reveal how the system worked. At Tonga-Briga, another Castro period bath complex was cut directly into granite bedrock. A Pedra Formosa separated the outer area from the sauna chamber through another low restricted entrance. Behind it lay the heated space associated with fire and hot stones. The complex continued into the early Roman period, showing that this local bathing tradition survived while Roman influence was expanding. Tonga-Briga also preserves a serpent motif on its stone, later altered by a Christian cross carved over the animal's head. The original meaning of the serpent remains unknown. That uncertainty is what makes Pedra Formosa compelling. Archaeology can now explain much of the mechanism. Fire generated heat, stones were warmed, water created steam, and the tiny opening reduced heat loss. What it cannot explain with the same confidence is why the entrance became such a monumental object, why it was decorated so carefully, or whether crawling through it carried symbolic meaning. The threshold controlled temperature, movement, and visibility at the same time. Anyone entering the chamber had to lower the body beneath a massive decorated slab before disappearing into heat, darkness, and steam. Whether that was simply efficient engineering or part of a ritualized experience remains unresolved. Pedra Formosa therefore preserves a more credible mystery than any claim of lost technology. The engineering is understandable, and the bathhouse function is supported by archaeology, but the cultural meaning has largely vanished. More than 2,000 years ago, people at Prateros entered a structure where stone, fire, water, and steam were carefully controlled, and the final barrier was a granite slab nearly 3 meters wide with a doorway barely large enough to pass through. We can reconstruct how the chamber became hot, where people moved, and how the building was damaged over time. What remains uncertain is why crossing into that room required such an elaborate and deliberately constricted passage, and what that act meant to the people who built it. The Bashplemi Lake tablet presents an unusual archaeological problem. 60 carefully carved signs survive on a piece of volcanic stone, yet no one can say with certainty what they record, what language they represent, or even which direction they were meant to be read. The artifact was discovered in the autumn of 2021 near Bashplemi Lake in the Dmanisi municipality of southern Georgia, when local people fishing in the artificially impounded lake encountered an engraved slab. Rather than resembling random scratches or simple decorative motifs, the marks appeared organized into deliberate sequences. Researchers later documented 60 signs distributed across 7 horizontal registers, with 39 distinct forms among them. Some occur only once, others repeat 2 or 3 times, while one small mark interpreted as a possible punctuation sign appears 4 times. The combination of repetition, ordering, and separation convinced the research team that the marks represented a structured inscription rather than an accidental collection of symbols, but identifying the system behind them has proved far more difficult. The object itself is approximately the size of a small book, measuring 24.1 by 20.1 centimeters, and varying between 0.8 and 1.8 centimeters in thickness. Its density was measured at approximately 2.6 grams per cubic centimeter. Optical and electron microscopy carried out at Georgian Technical University, together with mineralogical examination, identified the material as vesicular basalt, a volcanic rock common in the surrounding region. This is important because it supports a local source for the stone, rather than suggesting that a finished tablet was transported into the area from some distant center of literacy. Basalt, however, is a hard material to engrave, and microscopic examination revealed evidence of a deliberate multi-stage technique. Pointed notches preserved inside the grooves indicate that the maker first established parts of the symbols, using a conical drilling implement. The resulting points were then connected and modified with a smoother, round-headed tool, possibly accompanied by abrasive material. Whoever produced the inscription, therefore, invested considerably more effort than would have been necessary for temporary marks scratched onto clay, wood, or another softer surface. Its age introduces another layer of uncertainty. The tablet itself has not provided a simple absolute date, and its discovery was not made during a controlled excavation in an undisturbed archaeological layer. Researchers instead examined the archaeological landscape around Bashplemi Lake. Surveys and drone photography indicated archaeological activity in the area, while surface finds included pottery fragments, a stone mortar, and pieces of obsidian that point toward Bronze Age occupation. On this basis, the archaeological context has been tentatively associated with the Late Bronze Age or Early Iron Age. The distinction is critical. The proposed date is based on context rather than a securely sealed deposit containing the tablet. The artifact may therefore belong to this ancient landscape, but its precise chronology remains unresolved. This uncertainty prevents the inscription from being placed confidently into the known development of writing in the Caucasus. The arrangement of the inscription makes the problem even more intriguing. Researchers divided the surviving text into 7 registers. The first contains 6 signs, the second 12, while the remaining lines vary considerably in length, with the final 2 registers containing only 3 surviving signs each. 21 of the 39 distinct signs appear only once. 13 forms occur twice, 3 appear 3 times, and the possible punctuation mark occurs 4 times. Another symbol composed of 3 vertically aligned points may have served as a divider, or perhaps represented a numeral. Such internal repetition is one reason the researchers argue that the inscription behaves like writing. Yet 60 total signs form an extremely small sample from which to reconstruct an unknown system. With no known bilingual inscription, no securely identified personal name, and no second substantial text written in exactly the same script, there is no equivalent of the Rosetta Stone that could provide a reliable starting point for decipherment. Even the reading direction remains unknown. The text could have been read from left to right or from right to left, and researchers have also considered boustrophedon, a system in which successive lines alternate direction. Certain repeated signs change orientation in ways that might support this possibility, but other repeated combinations do not behave as a consistent boustrophedon text should. Consequently, none of the proposed directions can yet be demonstrated. This means decipherment faces an unusually basic obstacle. Before determining what the symbols mean, researchers must first determine where sentences or phrases begin and in which direction their signs proceed. A mark, interpreted as punctuation, could eventually help solve this problem, but its function is itself uncertain. It could separate phrases, represent a number, or perform some entirely different role within the system. Comparison with other ancient scripts has produced similarities without producing an identification. The research team compared the Bashplemi characters with more than 20 writing traditions from the Caucasus, Near East, and Mediterranean world. Individual shapes show parallels with signs associated with Caucasian traditions, while others resemble characters found in Semitic, Brahmi, and North Iberian systems. The authors also considered possible relationships with early writing traditions known from Georgia, including signs associated with Gracliani Hill. Yet, no known script reproduces the Bashplemi inventory as a coherent system. This distinction matters because elementary geometric forms such as crosses, vertical strokes, arcs, circles, and combinations of straight lines can develop independently in unrelated writing systems. A visual resemblance between 2 characters cannot demonstrate that they represented the same sound or concept. Bashplemi therefore occupies an uncomfortable position. Many of its signs look vaguely familiar when examined individually, while the inscription as a whole remain unidentified. Damage to the tablet may have removed part of the evidence needed to understand it. A portion of the stone is broken away, particularly along the left side. Researchers cannot establish exactly how much material disappeared. The first register appears relatively centered and contains a surviving sequence that may indicate only limited loss, although an incomplete arc and inclined line near the damaged edge suggest that at least one register originally extended farther. The seventh register appears more complete, but even there the possibility of additional signs cannot be entirely excluded. It is also unknown whether the original object was deliberately shaped into a rectangular or elliptical tablet, or whether the inscription was simply carved onto a naturally suitable slab of basalt. Its irregular, largely unprocessed surfaces and edges leave both possibilities open. The absence of a translation also leaves the purpose of the object unresolved. Because the inscription was laboriously cut into hard basalt and contains symbols that may function as numbers or separators, the researchers considered several possibilities for its contents. It might have recorded military spoils, documented an important construction project, or represented an offering dedicated to a deity. None of these proposals constitutes a decipherment. They are attempts to explain why someone would choose durable volcanic stone for a relatively short formal inscription. If numerical information is present, an administrative or commemorative function becomes plausible. If the opening register contains an address to a ruler or deity, the tablet could instead have served a ceremonial purpose. Without recognizable words, however, these possibilities remain hypotheses.